Have you ever seen that picture of a nuclear fuel pool with that incredible, eerie blue glow and had a really weird thought? Like, what if I just jumped in? Well, that's exactly what we're going to break down today.
So let's literally dive into this question from a viewer named Jonathan. Now, it sounds completely insane, right? But the answer is actually packed with some seriously cool physics. The big question is, would you get fried in an instant? Or could you, actually take a quick swim?
Okay, first things first. Before we even get into the whole radiation thing, let's talk about the more normal dangers.
So, in a couple of ways, this pool is surprisingly ordinary. The water temperature is actually pretty nice, kind of like a warm bath, definitely cooler than a hot tub. So if you take radiation out of the picture, your biggest problem is just your own stamina. You'd probably get tired and drown long before anything else happened. But that's not really what this question is about, is it?
All right, now for the main event, the radiation. The absolute key to surviving this hypothetical swim is the very thing you're swimming in, because it turns out water is an unbelievable shield against radiation.
And this number right here, this is the secret to everything, 7 centimeters. Just remember that, because when we're talking about water shielding you from this kind of radiation, this is the magic number.
Yep, you heard that right. For the kind of high-energy radiation blasting off those spent fuel rods, every 7 centimeters of water, that's less than 3 inches, chops the radiation dose by 50%. It's what scientists call a half-value layer.
And this is where the power of compounding just gets wild. You add another 7 centimeters, and that radiation gets cut in half again, down to just 25% of the original. So by the time you have just a few meters of water between you and the fuel, the radiation level drops so fast that the dose you'd get is literally a billionth of what it is right next to the source. It's just gone.
So what does all this crazy exponential decay mean for our swimmer? Well, let's apply this idea to the actual layout of one of these pools.
This is the most important thing to understand. The pool basically has 2 totally different zones. Up at the surface, where you'd be treading water, the dose from those fuel rods way down at the bottom is practically 0. But if you were to dive down and actually touch one of those canisters, that's a fatal mistake. That would give you a lethal dose of radiation almost instantly.
And here's maybe the most counterintuitive, mind-bending fact in this whole thing. The water is such a fantastic shield that it not only blocks the radiation coming up from the fuel, but it also blocks the normal background radiation that we're all exposed to every single day from space and, from the Earth itself. So weirdly enough, you might actually get a lower total dose of radiation swimming in that pool than you would just walking down the street.
And look, this isn't all just theory and numbers. A real-life incident at a nuclear reactor in Switzerland proved these principles in a super dramatic and kind of terrifying way.
So back in 2010, a diver was doing some routine maintenance, and he found this little piece of tubing sitting at the bottom of the pool. His supervisor on the radio just told him, "Hey, pick it up and put it in your tool basket." But the second that basket started to lift out of the water, every single radiation alarm in the room just went absolutely nuts. They dropped it right back in the water, of course. The diver himself was totally fine, but the dosimeter on his hand showed it had gotten a massive, massive dose.
And this incident just perfectly illustrates the principle, right? The several feet of water between that radioactive object and the diver's chest and vital organs kept him completely safe. But his hand, which got right up close to it, it got sapped. It's the ultimate proof of how critical that water buffer really is.
So we've looked at the physics, we've got a real-world case study. I think it's time we finally got to the unexpected answer to Jonathan's original question.
So based on everything we've just gone over, the science is pretty clear. You stay near the surface, you definitely don't dive down to touch anything, and from a radiation standpoint, you should be totally fine. But there's one tiny little factor we haven't considered yet.
As one person who actually works at a research reactor put it, the biggest danger you'd face has absolutely nothing to do with radiation. It's the security. I mean, come on, these nuclear facilities are some of the most heavily guarded places on the planet. So the real threat isn't the physics, it's the armed guards whose entire job is to make sure you don't even think about trying something like this. And that kind of leaves us with one final funny thought to chew on. Well, a few feet of water provides incredible life-saving protection from lethal radiation. It turns out that a simple sign, backed up by some very serious security, is probably an even more effective shield against human curiosity.